So today we're going to talk about multiplying and dividing complex numbers. We're going to start out here with talking about the multiplying part. So we multiply complex numbers just like we would multiply polynomials. There may be an additional step, however. Remember to replace the I squared with a -1. So on this example, we got part A here. We got 7 times 4 minus 11i. So when we're looking at this, let's go ahead and distribute that 7 within the parentheses. So again, do a little rainbow effect there. The 7 times 4 and then a 7 times a -11. In which case 7 times 4 gives us 28, and then 7 times -11 gives us -77, and we still have that I for the imaginary value. And then in which case now, if we were to take part B here, we take 9 minus 5i times -2 plus 3i. We're going to use the FOIL method. All right, first, outer, inner, last. So again, you're going to take 9 times -2. Okay, then you're going to take 9 times plus 3i. Then you can take -5i times -2, and you can take -5i times a positive 3i. So now that we've got the FOIL set up, now we can just multiply through and simplify this a little bit further. So we can simply take, we get -18, 27i plus 10i minus 15i squared. So now, as we talked about up here, let's not forget to replace that I squared with a -i. So this I squared right here can be, not -i, -1. So -15i squared will be changed for us, all right? So we can take that, turn that into -1, which in all reality, just change that to a positive 15, right? Let's go ahead and combine the 27i and 10i as well, so give us 37i. So we should get -18 plus 37i plus 15. So now let's look at it in combine-like terms, because we can combine the -18 and the positive 15. We're allowed to combine these two guys right there. In which case, that should give us a -3, and we still have a plus 37i. And that's as simplified as we can get, and that is our final answer for that guy when multiplying through. Okay, so when we do this definition of the conjugate, right? A plus bi is the same. You multiply the conjugate as a minus bi. So the product of a complex number and its conjugate is always a real number. So let's look at this and do a FOIL with that, dealing with a conjugate number, okay? So as I said here, you got a plus bi times a minus bi. And we go forward and see what we got here. So then it turns out to be a squared minus abi plus abi, and then minus a b squared I squared. Well, it looks like we can replace the I squared with a -1. As well, these guys go away. So you have the same values. One's positive, one's negative, so they go away. So then we're left with a squared minus b squared times -1. So that just changes this negative b squared to a positive b squared. So as you can see, simplifying down, if you look at this and you multiply times the conjugate of this complex number, you get simply a squared plus b squared, with knowing your a value and your b value. So let's look at this in a summary. So the conjugate, as we just said, a plus bi is a minus bi. The product of those two is a real number. And we can find that by using the FOIL method, or by simply using the shortcut that we just showed you, as far as a squared plus b squared is going to give you the final when you do the FOIL method using that type of complex number. So let's do an example. So we have -7 plus 2i. By its conjugate, multiply negative 7 plus 2i by its conjugate using the formula that we have right there. So we'll just do this. So the conjugate of that is negative 7 minus 2i. This is our conjugate right there. So now if we do that and multiply this out, we simply know that our a is negative 7 and our b is a negative 2, right? Oh, sorry, this is a 2. That was negative 2, negative 2. So we should take this, in which case this should be a negative in here. Okay, so we should get negative 7 squared, which gives us 49, and a negative 2 squared should give us our positive 4. So negative 7 squared is 49, plus negative 2 squared is 4. Then we just combine them, and we should get 53. All right, let's do another example. So we're going to multiply negative 5 plus 4i by its conjugate. And using the formula a plus bi times a minus bi, we can simply put this in a plus a squared plus b squared. So our a value in this case is going to be negative 5. I'm going to write a first. I don't know why I wrote negative 5. A equals negative 5. And our b was all in the wrong spot. So the conjugate initially is negative 5 and negative 4i. So our a value is going to be negative 5. Our b value is going to be 4. So look at that. Now, before we move forward, I'll go ahead and make notation of this up here. Again, we could have left this simply as positive 2. So I already said either way it would have worked. As you saw, the square is going to make the negative go away. But so therefore, its point is to have the negative value in there. Our actual b value was 2 in this case because it was a positive 2 here and a negative 2 here. So therefore, the actual just b value itself is 2. So I apologize for saying it was negative earlier. That's what that case is. So down here again we have a positive 4 and a negative 4 for our b value. So our b value is just 4. So negative 5 squared, which should give us 25. And then we have plus 4 squared, which should give us 16. Now we just need to combine those. And 25 plus 16 is 41. Okay. So now let's look at division. Let's divide complex numbers. To rationalize the denominator of a radical expression like 2 divided by 3 plus square root of 5, we multiply the numerator and denominator by 3 minus square root of 5, which is the conjugate of the denominator. So we divide complex numbers in the same way. So procedure. To do this, divide complex numbers, multiply the numerator and denominator by the conjugate of the denominator. Write the quotient in the form a plus bi. So let's look at an example here and do this. So we're going to divide, write the quotient in the form of a plus bi. So we have 9 divided by 6 plus 3i. So we're going to need to multiply by the conjugate. Well, the conjugate is simply going to be our 6 minus 3i. All right, the conjugate simply should be 6 minus 3i, just like this. Okay, 6 minus 3i on the top and the bottom, multiplying numerator and denominator. So to do this, as it says, we're going to multiply numerator and denominator by the conjugate of the denominator. And it's just like we wrote up here. So we have 6 minus 3i on the numerator and 6 minus 3i on the denominator. We'll multiply this through. So multiply them, and let's go ahead and use this little trick that we learned, right, for the denominator. this will be pretty helpful on the denominator. Again, it's not the numerator, it's just the denominator, so the bottom portion of the fraction here. So in which case, on the bottom, we should have our a is a 6, and our b is a 3. So we'll take 6 squared plus 3 squared on the denominator. And up top, we should have 9 times 6, and then 9. So we'll take 9 times 6, and we'll take 9 times negative 3i. So 9 times 6 should give us 54, and 9 times negative 3 should give us a negative 27. And that's what we get, 54 minus 27i. And then on the denominator, as we talked about, taking 6 squared plus 3 squared. So now let's go ahead and do a little bit of math. All right, let's simplify that a little bit further. So let's say 36 plus 9 on the denominator. And let's go ahead and combine those. So we'll give us 45 down there. And so now we just need to write the quotient in the form of a plus bi. So again, it looks pretty similar to that, but let's go ahead and break this into the two fractions that it is. So that puts it in 54 over 45 minus 27 over 45i. And now I just need to reduce these fractions a little bit. And to do so, we get 6 divided by 5 minus 3 divided by 5i. And that is our final answer we are looking for to sum this guy all up. All right, so that takes us through multiplication and division of complex numbers. You got 4 problems to check your understanding, so hope that explains things a little bit better, and I'll see you next time.